This PowerPoint and video is designed to help you understand triangulation. So we will often be given point A and point B and a known distance in between. And we'll need to find out something about point C and point D. So first of all, I want you to have a look at this and try and figure out how many triangles you can see. Hopefully you can see this triangle here, this one here, this one here, this one here, but also this larger one, this one here, and that one sort of along the top on the left, and this one along the top on the right. So we have a lot of options for what we're going to be working with, and we'll get into which choices to make a little bit later. When you're given this kind of scenario, you'll be told some particular pieces of information. So you'll know how far apart A and B are from each other, and you'll know that the person or the thing at point A can look at point C and point D, and they'll have certain bearings that you'll know. So for example, here we've got 37.91 degrees to point D, and we've got 61.2 degrees to point C, in comparison to if A looked directly over towards B. B, on the other hand, has an angle of 43.24 degrees to C and 62.95 degrees to D. Once you know these four angles, you can work out almost all of the rest of the angles in this picture, and we'll go through how to do that now. So looking over here at A, we need to work out this small angle here. So you're going to take 61.2, subtract the smaller angle 37.91, and you'll get the leftover rotation, which is 23.29. Similarly, over here at point B, we'll take the larger angle, subtract the smaller angle, and we'll find that that smaller angle is 19.71. Now that we know this angle and this angle, we can look at this triangle here and say it needs to add up to 180. So if we go 180 and we subtract those two angles, we'll find the leftover angle here, 98.85. As soon as you found 98.85 there, you can copy it over to the location just above it. And once you have either of these, we know that a straight line is 180. So 180 minus this angle that we already know will give us the leftover, the 81.15. And we also know that that angle will be the same there. Now we're going to zoom in on this triangle here, of which we know this small angle here and this angle here. So 180, subtract those two angles, will give us the leftover angle there of 75.56. And we'll do exactly the same thing with this triangle here. 180, subtract the two known angles to find the unknown angle, 79.14 degrees. The only angles that we don't know in this figure are this one here and this one here. And if you're asked a question about finding a bearing from C to D or from D to C, you're going to need to eventually work those out. But that will only be after you've found the distance first. In this video, we're going to concentrate on looking at the distance. So I'm going to get rid of all of the kind of excess information from this slide, and now you can see all of our known angles and our 25-kilometre distance between point A and point B. We know a lot about this situation now, but what we really need to do is we need to use some triangles that use this 25-kilometre distance. So we had about 8 triangles that we could choose from, but we only have 2 now that we want to focus on to complete this next part of the problem. So this is one of the triangles here. This triangle here is going to help us find this side length here. Then we're going to focus on a different triangle, this one here, and that's going to help us find this side length here. The great thing about finding those two side lengths is once we know those two, and we know the angle in between, we are going to be able to work out this side length here, which is often going to be one of the things that you will be asked in a SAC or in an exam. So let's put this triangle up here with all of its known angles within it, and of course the 25-kilometer distance that we know. And let's put this triangle up here, again with all of its known angles and the 25-kilometer distance, and get rid of this in the middle. Let's call our unknown distance here x and the unknown distance here y. So we can set up a sine rule situation here because we know a distance and an opposite angle. So we know that 25 over sine 75.56 is the same as, and this is our unknown here, x over sine of 43.24. Then we just need to go ahead and solve, and we get 17.69 kilometers. Very similar over here, we're going to set up our sine rule with these two numbers. 25 over sine 79.14 equals y over sine of 62.95. Solving for y will give us 22.67 kilometers. Let's go back to our original diagram and let's put our 17.69 kilometers on that side there. Let's put our 22.67 kilometers on that side there. And I've gotten rid of all of the other information that wasn't really very useful now. And you can see now we've got two distances and a wedged angle. Hopefully, as soon as you see that, you know to go for the cosine rule. There it is there. So we want to do the square root of one of the sides. Let's just call this one here b, 17.69 squared. Let's call c this side here, 22.67 squared, minus 2 times 17.69 times 22.67 times cosine of our known angle, the wedged angle down here. Typing all of that into your calculator will give you a distance of 9.5, and we are in kilometers for this. Let's put our 9.5 kilometers up the top. So now we know a lot about this triangle. We know now the distance between C and D, even though that distance was likely not accessible from points A and B. From here, I'm not going to go through it in this presentation, but have a look at it and have a think for yourself. If you need to find the bearing of D from C, you're going to need to work out the angle in here. And knowing these other angles in here, knowing the angle down here is going to help you do that. If you had to find the bearing of C from D, you're going to need to work out all of this angle all the way around here. Again, you're going to need to find out this angle in here. But now that we've got 3 side lengths, we've got an opposite angle, we can set up a sine rule for any of those kinds of calculations. So just remember, if you're doing anything with bearings, you need to drop in your north-south symbol and then work out things like, if you know this angle and this angle, you can work out this angle because all 3 of them together must equal 90 degrees. As soon as you know this angle in here, you know this small angle in here, and if you know that angle and that angle, you can subtract that angle and you'll be able to work out the difference there. So really just make sure you've had a look at the worked examples, you've had a look at Ed Rollo, you've had a think about it, and please let me know if you've got any questions. Right, I hope this video has helped you, and good luck with the rest of your study.